How do you take a messy infinite decimal and place it at a specific, repeatable point on a number line? Welcome to BIJU at Educator. If you want to master mathematical constructions step by step, make sure to like and subscribe. Take a look at this blank number line. Our first task is plotting the simplest baseline problem, the square root of 2. We start at 0. First, we draw a horizontal base exactly 1 unit long. From that point, we draw a perpendicular height, also exactly 1 unit long. When we close the shape, we form a right triangle. The Pythagorean theorem shows that 1 squared plus 1 squared equals 2. That means the length of our new hypotenuse is the square root of 2. Here is the step that translates our triangle back and swing it directly down onto the line. By using these, now we move to the next step up, finding the square root of 3. To find it, we use the root 2 hypotenuse as our new baseline. From the end of that line, we draw a brand new perpendicular line exactly 1 unit long. We connect that back to 0. Root 2 squared is 2, plus 1 squared is 3. Our new hypotenuse is the square root of 3. Take your compass, measure, and swing the new arc down to the line. We can continue chaining this process. Add a unit height, draw the hypotenuse, and swing down for root 4. Then root 5, root 6, and root 7. Pro tip, if you are doing this by hand, trace your final triangles onto a fresh sheet of paper. But if we need to plot much larger numbers, the drawing becomes crowded and unmanageable. 5 sequential triangles is inefficient. Instead, we can use the direct shortcut. We look for 2 perfect squares that sum to our target. 26 is 25 plus 1. That means we can construct it using a triangle with sides of 5 and 1. On the number line, we draw a base of 5 units and a height of 1. Measure the hypotenuse and swing the arc down to the line. Time for practice. Pop answers in the comments. Here are the solutions. Root 5 uses 2 and 1. Root 10 uses 3 and 1. And root 13 uses 3 and 2. Recognizing perfect square components allows us to leapfrog the repeated step of 11, which does not break cleanly into 2 perfect squares. We solve it by finding the closest base shortcut first. We build the root 10 triangle we just mapped out, a base of 3 and a height of 1. From here, we add a sequential step on top of our shortcut. We use the root 10 hypotenuse as our new baseline, add a 1 unit height, connect back to 0, and swing that arc down to mark root 11. By combining a single sequential step with a larger direct jump, we can reach any irrational number on the line. We've mapped a wide range of numbers using these methods. Rule 1. Break targets into 2 perfect squares to jump straight to the destination. Rule 2. If a number doesn't fit the shortcut, find the closest root first and build a 1 unit step on top. And Rule 3. Length to the number line. Using these construction techniques, we can locate any square root on the number line. Thank you for watching BIJU at Educator. If you learned something today, please like, subscribe, and tell me in the comments which math topic you want to see next.